Hey, I'm back! In this video lesson, I'll be discussing the following: Avogadro's number and mole concept, 2. Mole calculation, 3. Number of particle calculation, 4. Molar mass calculation, 5. Mass component calculation, 6. Percent composition from chemical formula, 7. Mole fraction calculation, 8. The determination of chemical formula from percentage composition. So make sure that you have with you your periodic table of elements, calculator, a pen, and a clean sheet of paper. So have yourself comfortably seated while watching this instructional video. After watching this instructional video, you are expected to calculate the empirical formula from the percent composition of a compound and calculate molecular formula given molar mass. What is stoichiometry? Stoichiometry is pronounced as stoichiometry from the Greek stoichion, which means element or part, and metron, which means measure. It is the study of quantitative aspects of decimal formulas and reactions. Atoms can form ions, molecules, or compounds. And ions, molecules, or compounds have formula mass. Atoms also have relative atomic mass. And relative atomic mass and formula mass are expressed in atomic mass unit. An atomic mass unit may be converted to grams. Particles or ions, molecules, or compounds undergo chemical reactions. And chemical reactions must be balanced based on law of conservation of mass. Chemical reactions involve reactants to form products. Let's have Avogadro's number and the mole concept. The main idea here is that mole refers to an Avogadro's number of particles of matter. Avogadro's number is denoted by a capital N. It is a constant used to quantify the number of particles of an element. It could be an atom or an ion. Or it can also be a compound, which is molecules or formula units. Note that molecule is the particle unit of covalent compound. Formula unit refers to ionic compounds. Avogadro's number is named in the honor of Italian scientist Amedeo Avogadro. The Avogadro's number has the value 6.022141 times 10 to the 23rd power, which is commonly rounded off to 6.022 times 10 to the 23rd particles per mole. Did you know that Avogadro's number is a really large number? To put its magnitude into perspective, consider the following numbers. The estimated Philippine population is 109 million. The universe is about 14 billion years old. The distance of Earth from the Sun is 149,598,000,000 meters. The hard drive in the computer has the capacity of 1 trillion bytes or terabytes. If someone has an Avogadro's number of 10 centavo coins, that person is zeta rich. So here is the figure for the Avogadro's number. Isn't it large? Over 1 million are words in the English language. Tens of millions is the Metro Manila's population. Over hundreds of millions is the Philippines' population. Tens of billions is the age of the universe. Over 100 of billions is the Earth's distance from the Sun. Over 1 trillion is the capacity of hard drive compared to the number of around 602 sextillion, 214 quintillion, 100 quadrillion of particle per mole, which could be an atom, an ion, a molecule, or a formula unit. Isn't it amazing? A mole of any particle of substance will have an Avogadro's number of that particle. This means that 1 mole is equal to 6.022 times 10 to the positive 23 particles. Particles can be atoms, molecules, ions, or formula units. 1 mole of gold is equal to 6.022 times 10 to the 23rd gold atoms. And 1 mole of gold ion is equal to 6.022 times 10 to the 23rd gold ions. 1 mole of carbon dioxide is equal to 6.022 times 10 to the 23rd carbon dioxide molecules. And 1 mole of sodium chloride is equal to 6.022 times 10 to the 23rd sodium chloride formula units. In 1 mole of compound, the number of moles of an atom or its corresponding ions from ionic compounds is equal to the atom's subscript in the chemical formula. This means that in 1 mole of sodium chloride, there is 1 mole sodium ion and 1 mole chloride ions. Similarly, 1 mole of carbon dioxide is equal to 6.022 times 10 to the 23rd carbon atoms, and also equal to 2 times 6.022 times 10 to the 23rd oxygen atoms. Like, in 1 mole of sodium chloride is equal to 6.022 times 10 to the 23rd sodium ions. And it also have 6.022 times 10 to the 23rd chloride ions. What is mole? Mole is a unit, mole or MOL, and a symbol of small n. It is a device to count entities by weighing them. The International Union of Pure and Applied Chemistry defined the mole as the amount of substance of a system which contain as many elementary entities as there are atoms in 0.012 kilograms of pure carbon-12. To calculate number of mole, we use the equation mole is equal to mass in grams divided by atomic mass or molar mass, and the unit is mole. atomic mass if we are referring to an element, and molar mass if we are referring to a compound. If we are to look for or calculate for the mass of the substance, we just manipulate the given equation and we will be having the formula mass is equal to number of moles multiplied by the atomic mass if it is an element, or molar mass if it is a compound. Or true symbol, mass is equal to N multiplied by atomic weight, or mm. So remember that mole can be calculated through this equation. Mole is equal to mass in gram all over atomic mass or atomic weight if the given substance is an element, and molar mass if the given substance is a compound. So let's have an example. How many moles are there in 85 grams of sodium? Sodium is an element, so therefore we're going to look for its atomic weight or molar mass. The atomic weight or molar mass of sodium can be found in your periodic table, and any other elements are written there. So, since we are looking for the number of mole, the expected quantities are the mass of sodium, which is 85 grams. The atomic weight of sodium written in the periodic table is 22.99 gram per mole. So let's agree that the atomic weight or molar masses of elements must be in a whole number. So rounded whole number. So 22.99 can be rounded to 23 gram per mole. And the mole of sodium is unknown. So let's have the solution part. So, mole of sodium, we are now going to calculate the mole of sodium, we are now going to substitute the given values. The mass of sodium is 85 grams, and the atomic weight of sodium in whole number is 23 gram per mole. So you can now cancel gram together, leaving the unit mole. So you just simply press in your calculator 85 divided by 23, and you will get 3.70 mole. So the mole of sodium is 3.70 mole. I hope that is very clear to you. What if you are asked to calculate for the mass number given this equation? So let's have an example. Silver is used in jewelry and tableware, but no longer in US coin. How many grams of silver are in 0.0342 mole of silver? Rearranging this equation, we have now the new equation for calculating number of mass, which is mass can be calculated by multiplying the mole number with atomic weight if it is an element, or molar mass if it is a compound. So let's start with the given quantities. So what are the given quantities? The mass of silver is unknown. The atomic weight of silver is 108 gram per mole. Okay, 108 gram per mole is the rounded value that you can see in your periodic table for silver's atomic weight. And mole of silver, which is given in the problem, is 0.0342 mole. So let's try to compute. So mass of silver can now be calculated by multiplying N
with its atomic weight. So by substituting the values, the number of mole is 0.0342 mole multiplied by 108 gram per mole. So you can now cancel mole and mole. And you only have now the unit of mass, which is gram. So the mass of silver is equal to 3.69 gram of silver. Let's have number of particles. Number of particles can be calculated by multiplying capital N, which is your Avogadro's number, multiplied by small n, which is your number of moles. A particle can be an atom or atoms. Example of atoms are sodium, magnesium atom, and calcium atom. Particles can also be ions. Example of ions are sodium ion, magnesium ion, and carbonate ion. Particles can also be molecules. Example of molecules are water, carbon dioxide, sugar. And particles can also be formula units. Examples of formula unit are sodium chloride, formula unit of magnesium oxide, and formula unit of calcium carbonate. Again, your capital N is Avogadro's number, which is equal to 6.022 times 10 to the 23rd particle per mole. And your small n is number of moles. Remember that number of particles can be calculated by multiplying the Avogadro's number with the number of mole. For example, determine the number of particles of 0.5 mole silver, or AJ. Of course, in doing some calculations, we always start with the given quantities. And the given quantities are number or mole of silver is equal to 0.5 mole. For the Avogadro's number, which is constant, it is 6.022 times 10 to the 23rd atoms per mole. So, for the solution, in order to compute for the number of particles of silver, we just simply substitute the values. So we have the Avogadro's number, which is 6.022 times 10 to the 23rd atoms per mole, multiplied by 0.5 mole. So you can now cancel mole and mole. And we have here the number of atoms remaining. And you will get 3.011 times 10 to the 23rd atoms of silver. So easy, right? So let's talk about molar mass, or mm. What is molar mass and how to compute molar mass? The mass of one mole of an element or compound is called its molar mass, or mm, which is numerically equal to the atomic mass of an element. The molecular mass of equivalent compound, or the formula mass of an ionic compound. It is expressed in grams per mole. The molar mass is obtained as the sum of the product of the atomic masses and the number of atoms of every element that comprise the compound. Let's have an example. Calculate the molar mass of sodium phosphate with the chemical formula Na3PO4. And to do the calculation, first step is know the atomic masses of the component of that compound. So for sodium, it is equal to 23 gram per mole. For phosphorus, it is equal to 31 gram per mole. And for oxygen, it is equal to 16 gram per mole. So let's try to calculate the molar mass of sodium phosphate. First, look for the number of atoms of the present particular element in that compound. In this particular compound, we have three components. We have sodium, phosphorus, and oxygen. For sodium, we have three atoms. Okay, so three atoms multiplied by the atomic weight or the atomic mass of sodium, which is 23 gram per mole, and you will get 69 gram per mole. For phosphorus, we only have one atom, so that would be 1 multiplied by its atomic mass, which is 31 gram per mole, and you will get 31 gram per mole. While for oxygen, we have 4 atoms, so we have to multiply 4 with its atomic mass, which is 16 gram per mole, and that is equal to 64 gram per mole. And we'll get the sum, and that's our molar mass. And the sum is 169 gram per mole. So the molar mass of sodium phosphate is 169 gram per mole. Isn't it easy? This time, let's have a problem that requires multiple answers. In this particular example, you just have to apply all the concepts that are being discussed a while back. These are the number of mole, number of particle, and molar mass. So let's have an example. Determine the A, number of particle, and the B, mass of 0.85 mole copper. Remember your number of mole. Number of mole can be calculated by dividing the mass in grams of the substance all over the atomic mass if it is an element and molar mass if it is a compound. In this particular example or problem, we're going to use two particular equations. For letter A, we're going to use this equation. Number of particle is equal to the Avogadro's number multiplied by the mole number. While for letter B, in determining the mass of the substance, we just simply multiply the atomic weight and the mole number. Why atomic weight? Because the substance is copper, which is an element. Remember that in doing some calculations, we always start with the given quantities. And the given quantities are, for mole copper, we have 0.85 mole. While the atomic mass or atomic weight of copper is equal to 64 gram per mole. 64 gram per mole is taken from the periodic table, the atomic weight or the rounded atomic weight or atomic mass of copper. And lastly, we have the Avogadro's number constant, which is 6.022 times 10 to the 23rd atoms per mole. Why atom or atoms? Because the substance is an element. In this case, it's copper. So let's proceed to the solution part. For letter A, number of copper particles, we just simply multiply the Avogadro's number, which is 6.022 times 10 to the 23rd atoms per mole. If you are using scientific calculator, you just press 6, then 0.022, and then you will see the symbol EXP in your calculator. Press that and press 23. EXP means exponent. okay, multiplied by 0.85 mole. So you can now cancel mole and mole. And you have here the unit sought for, which is atoms. So we have 5.1187 times 10 to the 23rd atoms of copper. For letter B, the mass of copper can be calculated by multiplying the atomic weight and the mole number. Okay, the mole number is 0.85 moles multiplied by 64 gram per mole. Okay, these two can be interchanged. Okay, okay lang, walang problema. So we have here, we can now cancel mole together, and we have the unit sought for, which is in gram. So it will give you 54.4 gram of copper. So easy, right? How about if you are asked to compute for the mass of particular component of a compound? It is very simple. Just follow or use this equation. Mass components is equal to the atomic weight of that component in a compound multiplied by the number of atoms of that component in a compound multiplied by the mass of compound divided by the molar mass of the compound. So let's have an example. How many grams of hydrogen are present in 65 grams of glucose? Glucose has a chemical formula C6H12O6, which has a molar mass of 180 grams per mole. Remember that hydrogen is the component, is one of the components of this compound, and we are going to calculate for its mass. Again, it is very important to start with the given quantities, and the expected quantities or values are the following. The mass of glucose is 65 grams. The molar mass of glucose is 180 grams per mole. And the atomic weight of the component hydrogen is 1 gram per mole. Remember that 1 gram per mole is the value that can be taken from the periodic table. And of course, the mass of the component, which is hydrogen, is unknown. Now let's have the solution part. The mass of the component, which is hydrogen, is equal to 1 gram per mole, which is the atomic weight of that component. In this case, it's the hydrogen, multiplied by the number of atoms of hydrogen in the compound, which is 12, multiplied by 65 grams of, or the mass of glucose, divided by the molar mass of glucose or the compound, which is 180 grams per mole. To simplify this equation, we have 1 times 12 is equal to 12 grams per mole, multiplied by 65 grams, which is the mass of the compound, divided by 180 grams per mole. Here, you can cancel gram per mole and gram per mole, leaving the unit sought for, which is the mass of the component, which is hydrogen, in grams. And we will get 4.33 grams of hydrogen, meaning to say there is 4.33 grams of hydrogen for every 65 grams of glucose. I hope that is very clear to you. For your first task, solve the following word problems. For items 1 and 2, you are just going to calculate for the molar masses of the compounds. For item number 3, you need to show two answers. One for number of mole and the other one for the number of particles. Remember that when you are asked to compute for number of atoms, ions, formula units, and or molecules, it means that you are going to calculate for the number of particles. For number 4, you're going to calculate for the mass of components. And for number 5, calculate for the mass of the compound using this formula or equation. Good luck! Now, I'll be discussing percent composition and chemical formulas. The main idea here is that a compound contains a constant proportion, that is by mass, of its constituent elements. In percent composition from chemical formula, the mass of each element in a chemical formula as well as its percent composition in the compound may be obtained. The general formula for calculating the percent composition of an element in a compound is given by percent A is equal to atomic mass of A multiplied by the number of atoms of A in a compound divided by formula or molecular mass or molar mass of the compound multiplied by 100%, where A is the element of interest. Let's try to compute percentage composition from chemical formula. And here's the problem. Sodium carbonate with a chemical formula Na2CO3 is commonly used as an additive in the manufacture of glass, or as water softener and neutralizer for chlorine in pools. It is commonly known as soda ash or washing soda. What are the percentages of each element in the compound? The atomic masses of the element in the compound are the following. For sodium, it is equal to 23 gram per mole. For carbon, it is equal to 12 gram per mole. And for oxygen, the atomic weight or the atomic mass is 16 gram per mole. To compute for the percentage composition, multiply the atomic mass of that component to the number of atoms of that component present in a compound, divided by the molar mass of the compound. Since molar mass is needed and it's not given in the problem, you need to compute first for the molar mass of the compound. And here is how to compute the molar mass of sodium carbonate. Let's start with sodium. Sodium with 2 atoms in the compound multiplied by 23 or the atomic mass will give you 46 gram per mole. While for carbon, having 1 atom in the compound multiplied by 12, which is the atomic mass of carbon, will give you 12 gram per mole. While for oxygen, having 3 atoms multiplied by its atomic mass, which is 16 gram per mole, will give you 48 gram per mole. To sum up, it is 106 gram per mole, and that is the molar mass of sodium carbonate. So here is the simplified calculations for each of the components of the compound. For percentage by mass sodium, we have 46 gram per mole. 46 gram per mole is taken here, divided by the molar mass of the compound, which is this one, 106 gram per mole. We'll multiply it by 100%, and it will give you 43.40% of sodium in that compound. For percentage by mass carbon, it will be calculated by dividing 12 gram per mole which is taken here, divided by the molar mass of the compound sodium carbonate, which is 106 gram per mole, multiplied by 100%, and you will get 11.32%. And lastly, for the percentage by mass oxygen, it will be derived from dividing 48 gram per mole taken from this, divided by 106 gram per mole, the molar mass of sodium bicarbonate, multiplied by 100% will give you 45.28%. To sum up, it is equal to exactly 100%. The percent composition of all the elements composing a compound should always add up to 100%. I hope that is very clear to you. This time, I'll be discussing mole fraction with the symbol small n sub small f. To calculate for mole fraction, mole of element in compound is divided by small of element in compound. So let's have an example. A sample of ionic compound showed 0.12 mole of sodium, 0.12 mole of chlorine, and 0.49 mole of oxygen. Calculate for the mole fraction. So let's start by the given quantities. Mole of sodium is 0.12 mole. Mole of chlorine is 0.12 mole as well. And for oxygen, it is 0.49 mole. So let's try to compute now for the mole fraction. Mole fraction sodium is equal to the mole of sodium divided by the smallest mole. And the smallest mole of element in the compound is 0.12 also. So divided by 0.12 is equal to 1. For mole fraction chlorine, we have 0.12 mole also. And divided by the smallest mole of element in compound, which is 0.12. It is equal to 1 also. While for oxygen, the number of mole is 0.49 mole divided by the smallest mole of element in compound, and that is 12. It will give you 4. So that's how to compute for mole fraction. Did you know that the chemical formula of a known substance can be derived through the computed mole fraction? Yes, because the mole fraction of the component can be the number of atoms of that component in the compound. Like in this case, the ionic compound must be, for sodium we have 1 atom, for chlorine 1 atom also, and for oxygen we have 4 atoms. And we have the chemical formula NaClO4, or it's called as potassium perchlorate. And that is the chemical formula of that ionic compound. Did you get it? I hope so. Let's continue. If we can compute percent composition from chemical formula, we can also derive the chemical formula of the compound from the given percent composition of its constituents. This usually applies during the chemical analysis, when compound is broken down into its elements to determine its percent composition. So let's have an example. Identify the molecular formula of the compound that was found to contain 40% carbon, 6.71 hydrogen, and 53.29 oxygen. the molar mass of the compound is 60.00 gram per mole. Since the percentages are given, the convenient way to solve the problem is to assume that 100 gram of compound is composed of the elements with masses corresponding to their percentages. This follows that in a known compound, there is 40 gram carbon, 6.71 gram hydrogen, and 53.29 gram oxygen. The masses are then converted to moles. Let's continue. Here are the given values in tabular form. Again, just to emphasize, we assume that 100 gram of compound is composed of the elements with masses corresponding to their percentages. Just like saying 40% of mass of carbon in 100 gram of that unknown compound is 40 gram of carbon, and 6.71% of mass of hydrogen in 100 gram of that unknown compound is equivalent to 6.71 gram of hydrogen, and 53.29% of mass of oxygen in 100 gram of that unknown compound is equivalent to 53.29 gram of oxygen. The atomic mass of carbon is 12 gram per mole. The atomic mass of hydrogen is 1 gram per mole. And the atomic mass of oxygen is 16 gram per mole. And the given molar mass of the compound is 60 gram per mole. In order to determine the chemical formula of that unknown compound, you must follow the following steps. Let's have the first step. Calculate mole of the entities. And to calculate the mole of the entities, just simply divide the given mass with its atomic mass. So for the number of mole of carbon, the mass of carbon is 40 gram divided by 12 gram per mole, which is the atomic mass. Here you can now cancel gram together, and the answer is 3.33 mole. For mole of hydrogen, we have the mass of hydrogen is 6.71 gram divided by 1 gram per mole. So cancel gram together, and you will get 6.71 mole. For mole of oxygen, we have 53.29 gram divided by 16 gram per mole. Cancel gram together, and then the value is 3.33 mole. Next step is calculate mole fraction. Remember that mole fraction can be calculated by dividing the mole of that entity with the smallest mole among the entities. So example, for carbon, we have the mole of carbon is 3.33, and the smallest mole among the entities is also 3.33. So the mole fraction for carbon is 1. You can cancel mole here. For mole fraction hydrogen, we have 6.71 mole divided by the smallest mole of the entities. We have 3.33 mole. So cancel mole again together, and you will get 2. For the mole fraction oxygen, it is equivalent to 3.33 mole divided by 3.33 mole also. Cancel mole and mole. And the mole fraction of oxygen is 1. Now we have step 3. Write the empirical formula or empirical formula of that unknown compound. It is derived from the calculated mole fraction of the entities. For carbon, we have 1 atom of carbon. For hydrogen, we have 2 atoms. And for oxygen, we have 1
atom. So the empirical formula is CH2O. After the derivation of the empirical formula, compute the empirical mass. In computing empirical mass, we follow the same procedure in calculating molar mass. And the empirical formula we have obtained a while back is CH2O. So to compute for the empirical mass, we have to multiply the number of atoms of that particular constituent with its atomic mass. So for carbon, we have one atom of it multiplied by 12, which is the atomic mass, will give you 12 gram per mole. For hydrogen, we have two atoms multiplied by 1, which is the atomic mass of hydrogen, and will give you 2 gram per mole. And for oxygen, we only have one atom multiplied by 16, which is the atomic mass of oxygen, and it will give you 16 gram per mole. Get the sum, and that would be your empirical mass, which is equal to 30 gram per mole. For the fifth and final step, derive the molecular formula by calculating the ratio of molar mass of the compound and its empirical mass with the equation ratio is equal to the given molar mass divided by the empirical mass. And the given molar mass is equal to 60 gram per mole. The empirical mass is 30 gram per mole. So let's substitute the values. Molar mass is 60 gram per mole divided by the empirical mass, which is 30 gram per mole. You can now cancel gram per mole and gram per mole units. And the ratio is equal to 2. And finally, multiply the computed ratio with the subscript of the empirical formula. So, for carbon, we have one atom of it in the empirical formula multiplied by the computed ratio, which is 2. So that would be 1 multiplied by 2 will give you 2 atoms of carbon. For hydrogen, we have 2 atoms in the empirical formula multiplied by 2, which is the ratio, will give you 4 atoms of hydrogen. And lastly, for oxygen, we have 1 atom in the empirical formula multiplied by 2, which is the ratio, will give you 2 atoms of oxygen. Therefore, the molecular formula of that unknown compound is C2H4O2. It is also known as acetic acid. And we're done. I hope that you were able to follow the 5 simple steps. Before I give you your second and final task, I want to commend everyone who made it this far. Congratulations! And for you to get an extra 25 points, just answer this question. How many times I appeared in this instructional video? Piece of cake, right? Just complete this sentence. Blank your answer for blank, which is adjective, chemistry teacher. For example, thrice for energetic chemistry teacher. And send your answer via personal message with my messenger account, NRA Sansano Obilio, or through text or call with my cell phone number 0955-255-8571. And here is your final task. There you go. Good luck! Goodbye, everyone!